This is a calculus question, number 42, on your 022 ETS Practice Math Test. Claire has this garden and she has P feet of fencing. So that amount is fixed. It is constant. It will not change. She wants to extend it along 3 sides of the garden with the wall forming the 4th side, as shown in the figure above. And she wants, and this is supposed to, or you are supposed to be maximizing the possible area. If you're maximizing area, you have to use the area function. Area equals length times width. All right. The thing is, what you've got to do is get this into a single variable, and we'll talk about that in just a second. Let's call this length though, and this width. All right. I want to quickly talk to you about why maximization works. With maximization problems, what you do is take the derivative, because the derivative is what will show you the slope. And do you remember that I talked about, I don't know why it keeps doing that, that the slope of the tangent line, you can actually tell by doing kind of little segment tangent lines there, that right here it's positive, which means the function would be increasing. Right here, it's negative. The slope is negative of that tangent line, which means that it's decreasing. However, maximum points have a slope of 0. So when we're maximizing, what we do is find the slope of the tangent line formula, which is the derivative. The derivative is the formula for the slope of the tangent line at any given point. But then we set it equal to 0, and that will solve for us what is either the maximum or the minimum. So looking at this, I've got area equals length times width. Okay. Now then, if P is the amount of fencing that I have, I will have to have 2 lengths and 1 width. So P is equal to 2 lengths and 1 width. Correct? So that means in terms of P, because I need to get a single variable isolated, I can say that subtract 2L here, and I can say that W is equal to P minus 2L. All right? Because that is the equation for the amount of fencing that I have. So if I do area equals length times width, I need to get it down to a single variable, and I can do that by, I have a new equivalent to W. W is called P minus 2L. So area is equal to PL, remember P is just a constant, minus 2L squared. My computer's messing up again. All right. So now what I'm going to do is take the derivative of that. So I'm going to say dAdL, which is another way of writing derivative. I could do A prime as well, is equal to the derivative. And remember, P is a constant, like if it were 2 or something. So the derivative of this is 1 times P, which is P. And then I subtract 1 from that exponent, which, subtract 1, which means 1 minus 1 is 0. So P times 1 is the derivative of that first term, minus, now then 2 times 2 is 4, and then L, and I subtract 1 from that exponent, and it's 4L to the first power. So the derivative is P minus 4. Sometimes if I change the color of the pen, it will stop doing this. P minus 4L. Okay, that is the derivative. Set that equal to 0. That will maximize your areas. Okay, so I'm going to subtract P. So I have negative 4L is equal to negative P. And remember, P is not a variable. P is a constant. It's just a constant. You don't know what it is. And I'm going to divide it by negative 4, divide by negative 4. So L is what you're isolating. L is the thing you really don't know. So that's P over 4. Well, if L is P over 4, what is W? And I can go back up to this equation and write W is equal to P minus 2 times P over 4. So W is equal to P minus 1/2 P, which means W is equal to 1/2 P. All right, so I know now in terms of P, which is what it asked for, what the maximum area dimensions are. But what it asked you for is which of the following expressions is equal to the maximum possible area. And area is found by multiplying the dimensions. And so I know that area is equal to length times width, which is going to be in terms of P over 4 times 1/2 P, or P over 2, which is going to be P squared over 8. That answer is D.